Good. Yeah. So this is a bit of a challenging day. I also managed to mess up the hours. So I had the assumption that I would have another sort of 8 hours or 6 hours or something like that to prepare my slides, which obviously turned out to be false. Anyway, so and I decided to make a to make a virtue out of that problem, and try to have basically only one slide, which I think works okay. We'll see how that pans out. So contrary to my usual sort of work nowadays, I will talk about something relatively theoretical today, namely about superintelligence. It's something that I used to work on a little bit more, and I spent some time as a research fellow at FHI in Oxford with Nick Bostrom, and I think Sean is here as well, and some other people. So I've occasionally been thinking about what is going on there, and so I think there is something problematic about what is going on in that superintelligence discussion. And I couldn't quite put my finger on why I felt there's something problematic. Now, in discussions with my PhD student, Michael Cannon, who's trying to write a PhD on super ethical machines. So how could machines not just be super intelligent, but also be super ethical? We sort of came into that discussion, how does intelligence and being ethical connect? And that made me think that maybe there's something problematic about the discussion. So here is my slide that summarizes the argument. Maybe it helps you just to have one so you can see where everything is going. So I put it in a somewhat medical terminology. So we have the symptoms first, then we have the diagnosis, then we have an attempt at therapy of the patient, and finally we have a prognosis. So we have 4 stages of that discussion. Okay. And so the symptoms, these are, I think, fairly well known, at least to philosophers, but lots of other people also. So I'll go over those relatively quickly. In the discussions that people like Bostrom, Kurzweil, Stuart Russell, and other people have pushed in recent years, there is a claim, which I still call the singularity claim, which is that artificial intelligence is on a trajectory that will lead to ever-improving systems for various technical and other reasons. They think that that's the case. And that trajectory will lead to devices that reach a human level of intelligence. And importantly, at that point, or somewhere around that point, there will be a point where the machines themselves will further that development. That's called the singularity. So the point where the development of AI is not something that humans make, but that the AI itself makes. So from that point onwards, we have a point where the machines reach our level of intelligence, roughly, right? Humans, there's a sort of space there, but it's not a very big space, actually. And from that point onwards, the machines themselves do the development. Either they develop systems or they have self-improving systems or something. It doesn't really matter. Okay, so the idea is, of course, that after that point, after the singularity point, we have super intelligence, so more than human level, and the whole thing is out of our control. The crucial thing is that control, right? And that is sort of scary to us as humans, right? Because we normally think that we are in control on Earth. Is pretty much true. On this planet, we're pretty much in control. And the reason, of course, why we are in control is because we are intelligent. It's not because we're strong or fast or anything like that, right? The intelligence is the thing that keeps us in control. So that's the singularity argument. Then the question is, where does that go? Is that something really, really good or really bad, or what kind of development is that? So Kurzweil, for example, thinks it's a tremendously positive development. We will have various technical advances that are great for us, and we will perhaps survive in a different technical form. And Bostrom, of course, thinks that there is a significant risk of destruction of the human species. so-called existential risk. Okay, so that is point B under 1 there. So in other words, we're now trying to speculate what happens after the point of singularity. And we don't really know that, but we sort of try to make various possibilities. And Bostrom, for example, thinks that it's either going to be very good or very bad, and more likely the second. It's not going to be just one technical development like many others, which are sort of have pros and cons, right? So this is where the argument moves from singularity to existential risk. So we might have machines that have their own aims and they pursue these aims, and they don't care about humans. So humans get killed in the process, or maybe they're even opposed to humans in some way. So then after a while of that discussion, people discovered that there is a bit of a gap in that argumentation. The gap is that we are assuming that these devices would be super intelligent, but they wouldn't behave ethically, at least the way we see ethical behavior, right? So that seems to be an interesting question. So how is being intelligent and being ethical related? That is point C on my slide, 1.C. So this was developed in something called the Orthogonality Thesis. So the Orthogonality Thesis quite simply says that being intelligent is, let's say, one dimension. You can think of it like the X on a Cartesian thing, and being an ethical is a different dimension. So you can have any point on any of these, these two dimensions. So you can be extremely intelligent but completely unethical, or extremely ethical and very unintelligent. All of these things are possible. And so the way this is often expressed, that's where it becomes a bit confusing, is that they say you can have any utility function and combine that with any kind of intelligence. So you can have any kind of aims. So you could have an intelligent being that says, I want to maximize pleasure on Earth and minimize pain, or you could have an intelligent agent that does the opposite, okay, and says, I want to maximize injustice on Earth. Okay, so that's the problem, and that is supposed to be the reason why there is existential risk. So really the sequence there in my ABC is not really correct. Strictly speaking, what's going on is that A and C are the premises and B is the conclusion. So I think there's something funny going on here. What is going on, it seems to me, is that they're using different notions of intelligence at different steps of the argumentation. So at the point where you're talking about this is going to reduce existential risk, it seems to me that we're thinking of something which I would call a general intelligence. So we will basically say, oh, it's sort of like us, but much smarter, much more of that, right? So it's usually, it is actually quite explicitly in Bostrom's writings, for example, it's left open. We're not really having a definition of intelligence. We are just sort of saying it's this kind of thing. You know what the intelligence is, right? So you sort of imagine a system that has these properties, and then it goes out of control. So there's a well-known paper by Omohandro, for example, where he imagines that we make a computer and we give it the task of playing maximally good chess. And then the computer discovers that, oh, in order to do that, I should try to get as much processing power as I possibly can. In order to get all this processing power, I need all the electricity. And it sort of starts taking over the world, switches off the electricity in the households and the hospitals and so on to get more and more electricity, become better and better at chess and produce better and better results. Okay, so I think there is a tension between that notion of intelligence, which is sort of what you would think, and the orthogonality, where you think intelligence is just pursuing a goal, but not thinking about the goals. This is the goal, right? So the famous example of the paperclip maximizer, give the machine the task to make as many paperclips as possible. It does that, and then it destroys the world in the process. It never thinks about why paperclip maximizing is a good idea. It just goes and does that, okay? So So I think there is a trick. I think they're using two different notions of intelligence in two different premises. And then, of course, the premises don't go together and cannot form the arguments. So there's something wrong. Okay, so that's the diagnosis at first glance, right? And so now let's see whether we can repair that. Obviously, there are two ways to repair this. A and B in my version there, 3A and 3B. So 3A is, obviously, it would be a repair if you could have general intelligence and orthogonality at the same time. So you could have intelligence of any sort you want, but it would be orthogonal. That doesn't look like a very promising proposal because it looks like you would have a being that would be intelligent in any way you want, but for some weird reason can't think about ethics. That seems really a strange idea. I mean, if you have intelligence, you can think of all sorts of things, but you don't understand that there is suffering in the world. You cannot understand the notion of justice. You don't grasp what a virtue is. You don't really understand why people behave the way they behave, right? I might do something for the reason that I think it's ethical to do this. That is the right thing to do. And the system wouldn't understand it. So I don't think that that's very promising. I don't think you can have general intelligence and orthogonality together. So this explains, I think, to some extent, that why this is puzzling. I remember Stuart Armstrong writing about this and saying he get this really weird responses that some people think orthogonality is obviously nonsense, right? These are the people who think of general intelligence. And some people think orthogonality is obviously true. So let's look at the other types, okay? So the other types would be those who say, okay, no, misunderstanding. When I said intelligence, I always meant instrumental intelligence, right? So I always meant something that is pursuing goals, or what Bostrom calls, has a utility function. What counts as positive, as good, pursuing these goals, and that's all it does. Now, it seems to me that it's hard to see how that could really be intelligence. One notion that we've been discussing in that context is the notion of frames. It's kind of old-fashioned. We thought the frame problem is kind of dead, but perhaps it's not after all. Maybe there's something interesting in it. So the difficulty in the notion of frames is that what you usually do is, when you're thinking about something, you're thinking about it in this instrumental way. So let's say you're in a room and you're trying to get out. Okay, so you see a door. The door has a doorknob on it, and you say, okay, good, I know how to get out. I go there and turn it. Okay, so you go there, you turn the knob, nothing happens. So you might turn it again and start noddling and things. At some point you might think, okay, well, maybe there's something wrong with my strategy here. So for example, the door is locked, right? Okay, yeah, let's check whether the door is locked. Maybe the door is jammed. Maybe you can check whether it's locked or not. It's not locked, and it's still not opening. Maybe it's jammed. Then you might see that the door is locked from the outside, for example. And you might start to think, okay, why is it blocked from the outside? You're moving, in other words, out of the frame, I want to get out of the room, to the, why is the door this way? And then you might say, oh, well, maybe the door is blocked from the outside because somebody's trying to prevent me from getting out. Okay. Now, another frame. Why are they preventing me from getting out? Is that because they're an evil prisoner and they're trying to imprison me? Or maybe the reason is that there is a tiger outside and they don't want me to go outside because it's dangerous to go out. Okay, so you move your thought from this instrumental, this target reaching with this technique, to thinking about the targets. Is that a good target or not? It seems hard to think how you could have a super intelligent system, not just intelligent in some way, but super intelligent system that shouldn't be able to do that, right? it seems to me these kinds of thoughts are elementary thoughts that we would have in all sorts of intelligent agents. And an automated car should be able to somehow think, okay, yes, I was supposed to go from A to B on that road, but now I see a big hole in the road, right? It's not a good idea to just plow on. Or I see a person in the road. Oh, no, it's not a good idea to plow on and kill the person and go ahead, right? So to think in what framework are we doing this and what matters here, what is it that matters, is an elementary part of thinking about the world. It is part of intelligence. So it seems really hard to see how you could be intelligent without having this ability to broaden into those frames. One footnote that occurs here is that some people who write about this seem to think that ethics is obviously an outside of intelligence and is obviously a completely relative thing. So that's point B2. So I talk about frames and now about relativity. Perhaps that is true, but it seems to me that that wouldn't really help you to get out of it. First of all, this doesn't mean we can't think about it at all. If it really means that you can have whatever aims you want together with whatever intelligence, so orthogonality is then trivially true because it's just relative. Anybody can have whatever ethics they like. So you could have first of all, you would have to say that that's what you think, right? If you think my singularity claim depends on the assumption that ethics is relative, okay, that would be good to know if that's the case. Secondly, I don't really see how that can fly because in that case, you wouldn't be able to talk about existential risk. Existential risk is supposed to be something negative, right? You're evaluating it as something bad. So that would seem to indicate that you are making a value judgment. You're making an ethical judgment that it would be bad if all the humans got killed, right? So it doesn't go with relativity. Relativity might say, oh, it's good if all the humans get killed. So let's look forward to it, right? So it doesn't seem that relativity will fly. So to sum that up, it seems to me that what the argument for the existential risk is trying to do is it's trying to have it both ways. It's trying to have intelligence that is just instrumental, just reaching predefined goals. And at the same time, it's trying to have a notion of intelligence that is general to make it more dangerous. And I don't think we can do that. We can't have it both ways. We have to have the one or the other. And I think what we're moving towards in AI is a better understanding that the kinds of systems we are making are instrumental intelligence systems. So they are relatively dumb because they don't do these framing things very well, which of course is a risk, right? Because they might do things which are really bad because they haven't thought about why is this important. But this also means that they're much easier to control than we thought because they cannot step out of those frames. So I don't think there's much of a reason to think that they produce existential risk. Okay, so it seems to me that there is a hole somewhere in the middle of that argumentation, which is that we don't have a notion of intelligence that can give us both of these things, the orthogonality and the existential risk at the same time. Thank you.
Thank you so much, Vincent, for the very thoughtful talk on superintelligence, the unethical with the two ways. So for those who are in video streaming, you can still ask questions, which will be taken by the speakers later. But I would like to raise a question to Vincent. I think Vincent and colleagues are one of the first to investigate on people's attitude towards when is AGI is going to happen. And I think the work has been for years. So I'm just want to ask, is anything changing your mind or people's attitude you would like to say when it's going to happen, or what is the challenge? Well, because several colleagues were later following the discussion, like Orion Zioni or colleagues, and And then they say, well, for example, the report was like, well, people say that, well, 25% of the AAAI fellow says it's not going to happen, but there's no output saying why that. So would you like to have some general comments?
Yeah, okay, so that's an interesting question, obviously. So Bostrom and I did a bit of a survey on that a couple of years ago, when we tried. Maybe I should wait. I should stop sharing my screen, right? When we tried to when we asked a lot of people basically on what they thought is the prognosis, and so the first thing to realize is that this is, as you of course indicated, it's a questionnaire about what people think, right, about their perception of this. And here I was discussing the question of whether the notion there is existential risk, if that does happen, is a sensible notion. So I am of the view that it is important to think about those things, even if we think that will never occur, because we could be wrong. Okay, so it's a bit like saying, oh, earthquakes are really unlikely to happen. That is true, right? I mean, even in a place like yours where earthquakes happen every now and then, it's really unlikely that we'll have an earthquake during our meeting today. I don't know what the probability is, but it's clearly way less than 0.1% or something like this. But that doesn't mean that it would be pointless to think about this, right? So it would be really bad if you had like a bookshelf like that one behind me next to you in an earthquake place without screws on the wall, and that one is bolted to the wall because I'm in Greece and there are earthquakes. So thinking about that is good, even if the probability is really low that it happens. So I could be wrong, and superintelligence is a fiction and never happens. It would still be useful to think about that, because I don't know that I will be wrong. So about the perception that you talked about, I think there is something like a hype cycle, right? In AI, I think everybody knows that we're now in a relatively high level of that hype, and a lot of people in AI are really scared about this because they know that a couple of years down the road, people will ask us, oh, weren't you the ones who are going to solve all these problems, and where are the solutions to that? So I remember, I think that was 2 years ago, roughly 2 years ago in the summer, I was presenting a talk about the problems of autonomous driving. And I suggested that these problems are really, really serious, and I do not see that autonomous driving on a big scale in a complicated environment like Beijing, for example, is likely to happen, right? Not like a highly regulated Californian highway, but something where messy things happen. And people were outraged. I mean, literally outraged about this, saying, why are you such a tech pessimist? And these things are already driving around in our home country in California, and this is happening. Now you can see that this hype is sort of moving towards a more realistic view. And I think the reason is that we've discovered that a lot of problems are harder than we think. And that we've discovered that on, you work on those problems, you know that better than me, but you discover this all the time, that a problem looks okay, when you look at it, I think I can solve that. And when you get into the nitty gritty of it, it becomes much, much harder than you thought. And especially, I think that's where this notion of the frame comes in, when you want to see in what context is this problem relevant and how does it connect to other problems that we have. So I am really, I find it really important to be humble about those things. And I think that is exactly what's going on in AI in these days in a lot of people's minds, that we should better be realistic about that. Some people because they're convinced, and some people because they're just afraid of the consequences. And so when Nick published his book, that was not what people thought, right? But in the meantime, I think a lot of people have come to the view that it might be a problem, that all these things will turn out to be much harder than we thought. And I think that's a positive development. We realize the complexity of the problems, even though we now have resources which are completely unheard of compared to what we had 10 years ago, right? I mean, you know that. I'm sure if you think about the budgets that you're now talking about in your institute compared to the budgets you were talking about 10 years ago, there's just no comparison. And that happens everywhere, right? So last footnote, I don't know whether you've seen this, there was a little paper some time ago where people were talking about Moore's law, you know, and had the increase in computing speed. And actually Moore's law is by far increase in computing speed to higher speed, right? So we don't double the computing speed every 2 years or so, but we double it actually every 4 months or so, because we just spend so much money on it, right? That is what's happening now.